Steve D'Antonio here with another in our series of instructional technical videos. The subject of this video is shore power transformers. We'll talk about what they can and can't do, how they might be beneficial to you, and what the options are. So there are really two types of shore power transformers. There's an isolation transformer and a polarization transformer. Interestingly, those two transformers are identical. The difference is primarily in how they are wired. So once they get on the boat, the people doing the wiring are the ones who determine, or the vessel's designer or electrical engineer, determine whether it will be a polarization transformer or an isolation transformer. Before I go into the differences between those two, let me tell you what both of those transformer scenarios will do, both polarization and isolation. Primary benefit of a shore power transformer is electrocution prevention. Without a transformer, shore power that leaks from a boat into the water around the boat presents an electrocution risk or an electric shock drowning risk. You can look at the end of this video, in the notes rather, you'll see a link to an article on that subject of electric shock drowning and how that occurs. But for the purposes of this presentation, it's important to understand that isolation and polarization transformers are both very effective in preventing the scenario that can lead to an electrocution or electric shock drowning. How do they do that? Well, once a transformer is installed on a boat, it essentially becomes the source of power, much like a generator or an inverter. And electricity always wants to return to its source. You'll often hear people say electricity wants to go to ground. That's really not fully accurate. It wants to go back to wherever it started from to complete the circuit. Well, if the transformer behaves like the source of power, it has no interest in the water around the boat anymore. Electricity that could potentially leak into the water and would otherwise want to travel back to its source, which is usually the transformer at the head of the dock or in the parking lot of the marina. It won't do that anymore when a transformer is present. It's going to go back to the transformer, so it doesn't travel through the water. So it makes the water around the boat safer. Now, let me be clear. You shouldn't be swimming around boats that are plugged into shore power, or docks for that matter, ever. But if somebody was swimming around a boat or fell in the water around a boat, or a diver was working on the boat, there is always this potential for electric shock drowning or in-water electrocution. The transformer, polarization or isolation, prevents that, or almost certainly prevents that from happening, makes it very unlikely. The other advantage to an isolation or polarization transformer is it maintains the correct polarity on the boat. If shore power comes into the boat, if that polarity from the dock is incorrect, the transformer really doesn't care. When that power leaves the transformer and goes out to the rest of the boat, it's guaranteed to be correct. You essentially can't make it wrong once it's leaving the transformer. Larger isolation or larger transformers like this one happens to be wired as an isolation transformer. Larger transformers like this typically have a 240 volt inlet, what we call a primary power that's being supplied to it, and then a 120 volt and 240 volt outlet for secondary. Again, whatever power is coming in, if it's incorrect in any way, typically the transformer will either correct it or it won't work at all, so they get no power on the boat, but that's better than having the wrong power on the boat. Now, if you wire the shore power transformer for isolation mode, it means there's no connection between the dock or shore ground and the vessel's ground, and it's being done safely. Once again, because this transformer has now become a source of power, the ground can originate inside the transformer. All faults will travel back to the transformer and ideally trip a circuit breaker, rendering them safe. Now, what's the advantage to having an isolation transformer? Well, it's disconnecting you from the dock. So that means if there's a boat next to you that is leaking current into the water and it wants to complete that path through the shore power ground, it can no longer do so because there is no connection between shore ground or dock ground and the boat's ground anymore. Or if the boat next to you has no zincs, your boat has zincs, your boat would normally be protecting that boat through the green shore power ground. You're both plugged into ground, so you're common. Your zincs could be protecting the boat next to you. The transformer prevents that because there's no connection between your boat's ground and the dock ground once a transformer is installed. That is only the case with an isolation transformer. Now, if you wire this as a polarization transformer, you don't have the benefit of that isolation. So what do? In that case, you need another piece of gear called a galvanic isolator. The galvanic isolator blocks galvanic current and voltage. So up to a certain point, it will protect the vessel from corrosion that originates on other boats. Mainly the case of the boat next door has no zincs anymore. Your zincs are protecting that vessel's zincs. If it's a straight current corrosion scenario on that other boat, and I talk more about that in our companion video about corrosion if you want to understand that more thoroughly. If that boat next to you has a straight current corrosion scenario, the galvanic isolator will not block that, and a polarization transformer will not block that. So if your goal is absolute isolation, then isolation wiring or wiring a transformer as an isolation transformer is the way to go. If that's not as important to you and you want only the electrocution prevention and the polarity protection, then wire it as a polarization transformer. Another potential benefit of a shore power transformer is its optional ability to boost low voltage. Why would that be important? Well, traditionally, if your vessel is wired for what we call split phase, otherwise known as 120 volt, 240 volt, if it's wired for that type of voltage, it's possible to plug into a dock that is providing, instead of 240, 208. It's fairly common in North America to encounter this. So that means that the equipment on the boat that's designed to run at 240 volts would instead run at 208, sometimes less because of voltage drop. On a hot day in the summertime, with all the air conditioning units running on a series of boats on a single dock, it's not unusual to see the voltage as low as 200 or 198 volts. So that means equipment on your boat that's designed to run at a higher voltage isn't getting that voltage. It runs hotter typically, and this primarily affects things like air conditioning compressors, refrigeration units, motors, air conditioning, raw water pumps, things of that sort that would normally run on 240 volts are now getting a lower voltage. They could potentially be damaged. If you have a transformer, isolation or polarization, that includes an optional boost feature, it can use some current, some amperage, to create a higher voltage. It converts current into voltage. So it can change a low voltage scenario of 208 or less volts into a more reasonable voltage of 220, 225, 230 volts. Better for the equipment on the boat. Now, in my opinion, a transformer should never be installed aboard a split phase boat that is not the boosting variety. Why do I say that? Well, obviously you want that benefit of being able to boost the voltage, but if you install a transformer that doesn't have the boosting feature on a split phase boat, again 240, 120, when you plug that boat into 208, that transformer is going to convert that to 208 and 104. So that means anything that's being plugged into a conventional outlet inside the boat will now, instead of getting 120 volts, will get 104 volts or less. Whatever the voltage that's coming into the boat, it will be cut in half for that 120 volt circuit. That can be especially detrimental to things like refrigerators. They don't like to run on low voltage, they tend to run hotter, and compressor life can be shorter in that case. So ironically, you are almost better off with no transformer than a non-boosting transformer because of that 208, 104 scenario. On a dock that is 208, if you don't have a transformer, you're going to get 208 and 120. If you do have a non-boosting transformer, you're going to get 208 and 104 on the boat. So again, if you're considering investing in a transformer, I absolutely recommend that it be a boosting variety of that transformer. Another option for transformers of the 240 volt variety, if your inlet is 240 volts, you can specify the option of having 120 volt primary or 120 volt inlet on that transformer, again as an option. When would you use that? Well, if you came into a dock that only had 120 volt shore power pedestal outlet available to you, you'd be able to plug into that. The transformer would convert that 120 to 120 240, again split phase on the boat. It could energize, therefore, anything on the boat, but not everything, because you'd be running at a lower overall wattage, but you still could choose what you were going to run on the boat. You wouldn't be dead in the water with the inability to plug in altogether. You'd get to plug into that 120 volt shore power dock pedestal, and again, it would energize all of the circuits on the boat, not simultaneously, because you'd need to load manage, because you'd have the same wattage as if you were plugging into a conventional 120 volt 30 amp dock outlet, but you do get the benefit of at least choosing what you're going to run on the boat, whether it's 120 or 240. So I recommend, if you're considering a transformer installation, that you select that option of 120 volt or 240 volt primary. Switchgear has to be installed to determine which one you're plugging into, of course, and you need a separate inlet for the 120, but that's a relatively small investment in the scheme of things, and the benefit is definitely worthwhile. Now, if you operate your vessel in North America, for instance, then the shore power is going to be what we call 60 hertz. That's the frequency of the shore power. But if you travel to other parts of the world, to Europe, to Australia, some South American countries, well, there the frequency will be 50 hertz. If your transformer is not designed to accept 50 or 60 hertz, if you plug a 60 hertz transformer into a 50 hertz shore power, even if the voltage is correct, the transformer will not work. It will not pass the power. So my recommendation is any transformer that gets installed, any 240 volt transformer that is, should be capable of operating on 50 or 60 hertz, because you really never know where the vessel may end up and what type of shore power environment it might end up in. You want it to be able to work on either 50 or 60 hertz. All right, another feature of shore power transformers, an optional feature, but an important one, is mounting it on a soft mount, like this bushing that's under this one. Transformers can hum or buzz a little bit when they're working. You don't want to transmit that to the rest of the vessel, especially if the transformer is near or abutting an accommodation space. You don't want to be listening to that noise or feeling that vibration while you're trying to sleep. So shore power transformers should be soft mounted on a flexible mount, sort of a motor mount, if you will, that will absorb that vibration and allow that transformer to float and not transmit that vibration into the boat. Now, it goes without saying that transformers are electrical pieces of equipment, and therefore they must be installed properly and fully in accordance with American Boat and Yacht Council guidelines. There's a chapter in ABYC called E11 that covers transformer installations, both polarization and isolation, and guides installers how to wire them properly and safely. Critically important that those guidelines be followed, as well as the installation instructions provided by the transformer manufacturer. Now, one of the key components in that installation, and one that is frequently violated, is the utilization of what's called a cord grip. That is absolutely essential for any transformer installation. What does that do? The cord grip prevents wires from chafing against the enclosure, the metallic enclosure of the transformer. If a wire chafes against that enclosure, it could potentially be an electrocution hazard. So it's critically important that that cannot happen. But what else does this cord grip do? Well, the name is a little bit of a giveaway. The grip prevents the wires from moving inside the transformer where the connections are made. So if I pull on these wires, I'm not moving anything inside the transformer because they're completely immobilized at this cord grip. This is probably the most commonly violated installation guideline for shore power transformers is failure to use a cord grip. You may see chafe protection, but that's only half the battle. You need to have full immobility of these wires so that they're not pulling on the connections inside the transformer. If I can move these wires in and out of however they're passing through the transformer, they've failed that test for the need for a cord grip. So make sure your installation fully complies and utilizes a cord grip that protects the wires from chafe as well as putting strain on the connections inside the transformer. As a final feature worth mentioning when we're talking about transformers, and again, isolation versus polarization. For a polarization transformer, the chassis or the metallic enclosure, the boat's ground, and the dock ground are all common. So if an energized wire on the primary or the secondary makes contact with the enclosure, in theory, it should trip the circuit breaker for either the inlet or the outlet on the transformer, rendering it safe. If the transformer is wired for isolation, that common ground is no longer there because we are isolating the dock ground from the boat ground for all the reasons I mentioned earlier. But when you do that, it does elevate the risk slightly because the grounds are no longer common. So it's possible for an energized wire to make contact with the chassis of the inverter or the enclosure and not trip a circuit breaker and have it energized and present an electrocution hazard. Now, if the transformer is wired properly, the likelihood of that happening is extremely low. American Boat and Yacht Council standards do provide for an isolation installation that is safe, provided all the instructions are followed, and among the most important being the cord grip and prevention for chafe, because if a wire can't chafe against this enclosure because that cord grip is there and it's installed properly, then there's no possibility of that case becoming energized and a potential electrocution hazard. So it's important to understand that that difference does exist between polarization and isolation, that there's that slightly elevated risk of electrocution. Personally, I believe it is minimal, provided the transformer is installed properly. Now, not all transformers are created equal. There are industrial transformers that are designed to be used ashore in factory and other commercial applications. And then there are transformers that are designed to be used specifically aboard boats. Ideally, I would like to see you use only transformers that are designed for marine applications and are fully compliant with American Boat and Yacht Council standards. There's several differences between a conventional transformer and one that's designed for utilization aboard a boat in a shore power application, either for isolation or polarization. The primary difference is the shield that exists, the metallic shield that is installed between the windings, the primary and secondary windings of the transformer. That shield prevents any arcing or otherwise inappropriate contact between those two windings in a variety of scenarios. And generally, when that transformer is installed, if it's installed as an isolation transformer, the shield is grounded to the shore ground. The chassis of the transformer is grounded to the boat's ground. If it's installed as a polarization transformer, all of the grounds are common: shore, shield, boat, and chassis. They're all connected together. If it's an ABYC compliant marine transformer, it'll meet those guidelines and it'll be the safest possible installation that you can have. Hi, Steve D'Antonio here in another of our technical instructional videos. Here at Deltaville Boatyard, they've been nice enough to make their facilities available to us to produce these presentations.